Welcome to another video. In this video, I want to solve a question on acid-base reaction. So the question goes thus. One volume of 0.50 molar H2SO4 is required to neutralize completely 2.80 gram of KOH, that is potassium hydroxide. So whenever you see this type of question, the first thing you are going to do is to write the chemistry of reaction. So there is no way we can solve this. We first write the chemistry of reaction. So solution. I'm going to write the chemistry of reaction between acid, that is H2SO4 tetrahydrosulfuric acid, and potassium hydroxide. As we know that neutralization reaction is reaction between an acid and a base to form salt and water only. So that means if I am to write the chemistry of reaction, I'm going to say that H2SO4 plus KOH. So we definitely give a product. So the product will be K2SO4 plus H2O. But if you look at this equation is not balanced. So let's try and balance it up. If I plug into here, let's check for the balancing. 2 hydrogen on the reactant, 2 hydrogen on the product. 1 sulfur on the reactant part, 1 sulfur on the product part. 4 oxygen here, 2 times 1, that is 2. Agglutination of 4 and 2 gives 6 oxygen. Okay? So I'm having 4 oxygen here, so that means I'm still going to put 2 here. So that is 2H2O. Now let's check. Now hydrogen, I'm having 2 here, I'm having another 2. That means the combination of 2 and 2 gives 4 hydrogen in total. 2 times 2, that is 4. Hydrogen is also balanced. Now let's check for oxygen. Oxygen, I'm having K2SO4, I'm having 2H2O. So I'm having 4 oxygen, I'm having another 2 oxygen. So agglutination of 4 and 2 gives 6. I'm having 4 at the product, I'm having another 2, that is 6. Everything is perfectly balanced. So if I want to write it out, that means 1 mole of tetrahydrosulfuric acid, then neutralized. How many moles of the base? 2 moles of KOH, according to this chemistry of reaction. Now, I'm going to say that the mass concentration of KOH, according to the context, is 2.80 gram. So I will definitely determine the molar mass of KOH. Let's try and determine the molar mass of KOH. So KOH, the molar mass, the atomic mass of potassium is 39. Then plus oxygen is what? 16. Hydrogen is what? 1. So when I add everything together, I get 56 gram per mole. So since I've determined the molar mass of that alkali, so I'm going to find the mole. So mole of KOH. From mole concept, mole is equal to what? Mass over what? Molar mass. So at this juncture, my mass is 2.80 from what? From the context. Then the molar mass has just been determined as what? As 56. So when I divide 2.8 by 56, it should give me 0.05 mole of KOH. Now, since from my chemistry of reaction, 1 mole of sulfuric acid neutralize 2 moles of what? The alkali. Now, I'm going to plug in this for the number of moles of KOH according to this expression. So that means X mole of H2SO4 will neutralize. Then the number of moles of KOH we just determined is what? 0.05 mole. So it is pertinent and germane to find the number of moles of H2SO4 from this reaction. So this is just a mathematical relation, proportion. So I'm going to cross multiply this with 1. I'm going to cross multiply x with this. So that means x times 2 is equal to what? 2x. Then 1 times 0.05 is equal to 0.05. So I'm going to isolate x. I'm going to make x the subject of the situation. If x is made the subject of the situation, I'm going to divide both sides by 2. So x is equal to 0.025 mole of what compound is that? Of sulfuric acid, H2SO4. Okay? Now, from the context, they ask us to determine the volume, but the concentration of that acid is known, which is 0.50 molar. So, how do we know there is a connection between the number of mole, concentration, and volume? According to the practical, I know that there is a particular relation that says Havana. That means the concentration multiplied by volumes gives what? Number of mole. So the same way for base, CV, VB, all over what? All over NU. So I will, since I'm dealing with the acid, I'm just relate this. So that means the number of mole of acid is equal to concentration of acid times volume of acid. From the context, they ask us to determine the volume. So we are going to isolate the volume from this context. So the volume of the acid will be equal to number of mole of acid over concentration of acid. So I'm going to plug in the number of mole. My number of mole for acid is what? 0.025 all over. Then the concentration of the acid in the context is 0.5. So I'm going to plug in 0.5. So the volume of the acid, 0.025 divided by 0.5 is equal to 0. That is equal to 0.05 dm cubed. So if I want to convert this to cm cubed, just multiply by 1000. That should give me 50 cm cubed. So hence, the volume of H2SO4 required is 50 cm cubed, which is also 0.05 dm cubed. So that is the end of the session. Line is continuous, line is differentiable, line is integrable, but not the best measurable. It is a diet.